When we picture a factory, we usually think of these loud, rigid assembly lines, right? Just stamping out the exact same thing over and over again. Well, that whole picture is getting a major update. Today, we're diving into what's next, the smart factory.
But first, let's start with a crazy question. What if a factory wasn't just a big, dumb machine? What if it could actually change its mind, adapt on the fly and react to problems or new orders in a split second? It sounds like something out of a movie, but believe me, it's happening as we speak.
So the idea driving this whole revolution has a name. It's called a Flexible Manufacturing System, or FMS. Now, the analogy here is just perfect. You have to forget the old factory model, that train stuck on a fixed track. Instead, picture a whole fleet of smart cars that can instantly find new routes if there's traffic, or if a customer suddenly changes their destination. That is the level of agility we're talking about.
Okay, so to really get our heads around this, here's our game plan. We'll kick things off with the big idea of the adaptive factory. Then we'll look at some real-world proof. After that, we'll check out the amazing results, face some of the big hurdles, and finally, take a little peek into the future that's, well, pretty much already here.
All right, Section 1, the factory that adapts. This is really the core of it all, this massive shift away from those clunky, unthinking production lines towards smart, responsive systems that can actually handle variety and chaos without breaking a sweat. Moving on to Section 2, proof in production. Theory is great and all, but where is this stuff actually working? Let's get into some really cool, real-world examples of FMS in action right now. First up, we're going big. We're talking about a study on the assembly line for M16 tipper trucks. And this isn't some small-time operation, this is heavy industry, exactly the place you'd think would be slow and hard to change. But they used FMS principles to simulate and totally rethink their entire process. And the potential here is just wow. The simulation showed that in some cases, they could slash the cycle time, that's the total time it takes to build one truck, by a mind-blowing 91.6%. Just let that sink in. You're not just making things a bit faster, you're operating on a completely different level of speed and efficiency.
But hey, this isn't just a game for the industrial giants. Let's switch gears to a totally different scale, a small to medium-sized clothing factory. The kind of business where production delays can be absolutely devastating. So for them, the goal was super practical. They used these smart manufacturing ideas to find the exact points where their process was getting jammed up. The key takeaway? They were able to create better schedules and slash the number of late deliveries, which, for a small company, can be the difference between sinking and swimming.
Okay, now for a taste of something really high-tech. Our third case study is about a factory that makes brass accessories. And what they did was create a digital twin, which is exactly what it sounds like, a perfect, real-time virtual copy of their entire factory floor, all running on a computer.
So what's the point of having this digital copy? Well, imagine a machine on the real factory floor suddenly breaks down. The digital twin sees it happen instantly, and then, in just seconds, it can run thousands of new scenarios to figure out the absolute best way to reschedule everything and reroute the work, all automatically. It's like the factory has a brain that solves problems the moment they happen. Which brings us right to Section 3, the astonishing results. We've seen the individual cases. Now let's zoom out and look at the hard numbers. Let's quantify the incredible impact these smart factories are having everywhere. Just look at this. In one factory that brought in AI, they saw the number of faulty products drop by almost 66%. So it's not just about being faster, it's about a huge leap in quality and cutting down on waste, all because the system is smart enough to see problems coming. And naturally, what happens when you make fewer mistakes and everything runs smoother? Your output goes through the roof. That very same factory saw a 25% jump in their total production. So they're making more stuff, and the stuff they're making is better. It is a total win-win. Now this next number is just wild. A 95.7% reduction in work in process. So what does that even mean? It means less half-finished stuff just sitting around taking up space and costing money. In a bottling plant, that's the difference between a smooth, constant flow and a system that's all clogged up.
And one more for you, a 44% cut in total flow time. That's the time it takes to go from raw materials to a finished product that's ready to go out the door. By making both the people and the machines more flexible, they almost cut that time in half. Products get to customers way faster, and the whole business can just react to change so much better.
So when you see results like these, you have to ask the obvious question, which is what our fourth section is all about. If this is so amazing, why isn't every single factory on Earth already doing it?
Well, the reality is, it's tough. The barriers are pretty huge. For starters, there's the massive upfront cost and the insane complexity of these systems. Then you have very real cybersecurity risks. There's also this gap between a perfect computer simulation and the messiness of the real world. Plus, companies are collecting mountains of data but not using it, and you need a workforce with a whole new set of skills.
And that point about data is just so crucial. This quote from one of the research papers is staggering. In one major factory, they found that less than 1% of all the data they were collecting was actually being used for anything useful before they brought in their new system. The potential is right there, but it's just being wasted.
But let's end on a high note with our final section, tomorrow's factory today. Because even with all the challenges, the innovation is not slowing down. Let's look at the cool new trends that are shaping the very near future of how we make things.
The next wave is already washing up on shore. We're seeing those digital twins become more and more common. We're getting AI that can actually explain its decisions to us humans, robots that learn and get better on their own, and maybe most importantly, a huge focus on using all this tech to create greener, low-carbon ways of manufacturing.
So, I'll just leave you with this final thought to chew on. For the past 100 years, we've been focused on building better and better machines. But maybe the next big thing isn't about the machine at all. Maybe the next truly great product will be made not just by a machine, but by a factory that can actually think for itself.